So in this video, we're going to take the skills that we know about covalent bonds, that they're composed of two electrons and they connect atoms together, and start to think about taking a chemical formula and creating or drawing a molecule. So we can use the valence electrons like we did in an earlier video, where we just said, hey, these two singles could come together to form a pair. So previously we looked at oxygen or hydrogen and oxygen, where we have H plus, two of those plus O. And this gives us HOH. So this works. We made a molecule. Everyone has octet. So what about NH3? So we can take N with its structure that looks like this, our three hydrogens, and we can imagine how those hydrogens just kind of fit into this molecule where we have nitrogen with a lone pair and three hydrogens. So all of these have octet, and they all just kind of fit together. But this is really impractical for compounds with multiple atoms. What about if we want to make something that isn't just one atom surrounded by a few others? What if we want to make a compound that maybe has 20 atoms or even more than that? How can we start to do that? So here are the guidelines that we're going to look at. One, you want to sum all the valence electrons for all atoms. You want to take into account the overall molecular charge. So you add if negative, and you subtract if positive. Because you want the number of electrons that you have to be consistent. So then you're going to write the symbols for the atoms and connect adjacent atoms. But we got to know how they connect. So sometimes you'll be given the atoms in the right structure, or sometimes the central atom will be first or is underlined. In most of these examples, it will be underlined. So then you want to take your valence electrons and give octet to all of the atoms connected to the central atom. So all of the exterior atoms should get octet first, and the remaining electrons go in the central atom. If there are not enough electrons left for octet on the central atom, multiple bonds are going to be required. So let's look at some examples. So we have CO2, CO, CH4, and H2CO. So the first step is to count your valence electrons. So for CO2, the valence electrons are 4 plus 2 times 6, and that is 16. Carbon is underlined, so it's going to go in the center. So now we're going to take our 16 electrons, now 12 because we've used 2, and put them to create octet. So 2, 4, 6, 8, 10, 12. Hey, look, these two oxygens have octet, but the carbon in the center doesn't. So what we're going to do is we are going to take one pair from each side and create a sharing component where the oxygen, each oxygen in carbon has 2 double bonds. No, between each oxygen and carbon there are 2 double bonds, which gives all 3 atoms octet. So now let's look at carbon monoxide. So our valence electrons are 4 plus 6, and that equals 10. So while the carbon is underlined, when you just have 2, it doesn't really matter. So now we're going to connect them together. I'm going to start on one side, 2, 4, 6, 8, 10. So now we do not have octet. So we need to create octet. So one thing we can do is donate this pair and this pair to give this, where each one has octet. Now you might have said, hey, well, why couldn't we use these and one pair from the oxygen? So we'll take that away. So if you have carbon and it's donated all of it to create this, this carbon has 6 electrons and this oxygen has 10. And so those violate octet. And so this is not realistic. So then we can do this for CH4 or methane. We have the valence electrons of 4 plus 4 times 1 gives us 8. We're going to connect each of these to our hydrogens. And it turns out we have used all of our valence electrons, and all of these atoms have octet. So what about H2CO? So now we have more than one. They're not all the same, but they are all connected to the carbon. But first, we need our valence electrons. 2 times 1 plus 4 plus 6, that equals 12. So from here, we're going to be able to put our carbon in the center, connect our hydrogen, connect a hydrogen, add an oxygen. So we've used 2, 4, 6 of our 12 electrons, 2, 4, 6, and we've used up all of our electrons. So in this case, the hydrogens have octet, oxygen octet, hydrogen, other hydrogen octet, but carbon doesn't. So we're going to use one of these pairs to create a lone pair to give us this structure where all of these compounds have octet. So as we start to do more and more examples like this, what we'll see is that the ability to create octet is really important.